Hi, I'm Mark Beardsley, an ecologist and restoration practitioner with Ecometrics in Buena Vista. I'm here to talk to you about partnering with beavers to restore Colorado mountain riverscapes. But first, close your eyes and try to picture the riverscape as I read to you. Looking back some 35 years, we find Trout Creek, a fine mountain stream, banks lined with willows and shrubs, well stocked with mountain trout. The surrounding hills are covered with good stands of pine and fir, and the parks are covered with thick grass. The same section today presents a sadly different picture. The mountain stream is converted to a deep gully with perpendicular walls and a boulder-strewn bottom. The willows and shrubs are gone, the timber's been cut from the hillsides, and the grass has been replaced by a few stands of ping and sage. What were once mountain meadows are now barren peat beds. You can open your eyes now. Is this what you pictured? Yeah, me too, when I read that. But this is a different stream, a neighboring stream. The stream I just described to you is actually this one. It's Trout Creek, and most of you have probably seen Trout Creek as you've driven along Highway 285 coming down into Buena Vista. Doesn't look at all like what I described, does it? It's kind of a lot sweeter. What's the catch? Well, what I didn't tell you is that the description I read came from a 1933 Civilian Conservation Corps report. And the video I just showed you is what that same riverscape looks like today. Back in the 1930s, in the grips of the Great Depression, a couple hundred out-of-work dudes descended on the degraded Trout Creek with hand tools, willow stems, and whatever materials they could gather on site to, in their words, bring back by human effort a portion of what man had destroyed. Those boys were doing low-tech process-based restoration. And it worked. Why do you think it worked? Well, I think it's because they had Mother Nature on their side. By partnering with beavers, they enabled nature's wetland ecosystem engineers. Beavers are the quintessential wetland ecosystem engineers. Their work supports species richness and landscape-level heterogeneity. They're the keystone species that maintains the health and resilience of the wetland ecosystems they live in. People are decent engineers, but when it comes to healthy streams and wetland, beaver have way more experience. In her book, The Beaver Manifesto, Glennis Hood reminds us that by the time early hominid ancestors appeared on this earth, a short 5 million years ago, beavers had already learned to cut wood and build homes. Castor canadensis, the species of beaver we have here in Colorado, has been in North America for 7.5 million years. Humans, on the other hand, have only been on this continent for 15 to 20,000 years, roughly 0.1% as long. And until just a few hundred years ago, there were lots more beavers than people here. Look at this little guy go. Beavers have everything you could want in a solid work partner. Smart, hardworking, meticulous, persistent, not to mention experienced, and not afraid to get their hands dirty. To hear us beaver aficionados talk, it sometimes sounds like we're describing a comic book superhero that's going to swoop in and save us. I'm guilty myself. One of my favorite sweatshirts is a hoodie with the Super Beaver logo. But of course they're just rodents. There's nothing at all magical about them. They have no superpowers. But what they do have is an unusual array of evolutionary adaptations that makes them specialized for living in the water. They have webbed feet and a big flat tail, which makes them amazingly graceful swimmers. Eyes and ears specialized for life in the water. They can hold their breath a really long time. They have an extra flap of tissue behind their teeth that they can close and so that they're able to chew and bite stuff under the water. And their fur's so dense it keeps them dry and insulated. They're also big and fat. Adult beavers tend to be around 60 to 70 pounds, the size of a Labrador retriever. The fat they store all summer keeps them alive through long winters. They're strict vegetarians, and mountain beavers survive winter by caching branches underwater to eat when they get iced in. More impressive than their adaptations to water, however, are their adaptations for manipulating their environment. Like most rodents, they have fossorial forepaws. That's just a fancy word for they're good at digging. And they have iron, hard chisel teeth that they use to cut trees. They're powerfully strong for their size, and they have senses that can detect moving water so they can plug it up. Lots of mammal species are adapted to life in water, but the beaver is unique in its ability to create the very wetlands they need to survive. In a long history of evolutionary development, Beavers came to inhabit arid environments like our Rocky Mountains, not by adapting to dry conditions, but by making dry places wet. I shot this video while camping in Taylor Park this summer. That mound of sticks you see in the middle of the pond, it's a lodge that the beavers built themselves. There's a dry chamber in the middle of there where the beavers can hang out, and the entrances are underwater. This beaver is busy packing mud on the walls to make it hard and insulated for winter. The leafy willows in front of the lodge that the beaver's swimming by right now, they're a food cache that the beavers put there. When this pond freezes over, which will probably be doing any day now, the store of food remains accessible to them under the ice. Here's a picture of what a typical beaver lodge looks like in the winter. The lodge is back to the right, and that pile of sticks frozen in the ice is the top of a food cache. Most of it's down below. Some of those bubbles that you see in the ice are actually frozen beaver breath from when they swim out from the lodge under the ice to sneak a snack. These are just a few more pictures of Beaverworld in winter. And that's Sarah Marshall down in the lower right photo. I don't think I've ever seen Sarah not smiling. Not even when it's below zero, as long as she's outside in a beavery wetland. And this is just a cool picture my friend Dave took of that same beaver in the video. Not only do beavers build those lodges in and around ponds, they also build the ponds and wetlands themselves. This is one of the kid beavers, probably a 1.5-year-old, packing mud and sticks onto a 3-foot tall beaver dam. That dam that she's built is the sole reason that there's a pond and wetland here at all. She's digging the mud up from the bed, so she's actually making the pond deeper in 2 ways, by digging it down and by raising the water level up. And here's Dave displaying his photography skills again. Okay, Dave, now you're just showing off. The point of this is to help you understand why beavers do what they do. It's just how they make a living. Beavers build their wetlands homes like their lives depend on it. And that's because their lives do depend on it, and so do the lives of so many other species. Colorado Parks and Wildlife refers to species like beaver as umbrella species. That's because conservation of an umbrella species leads to the conservation of so many other species that depend on them. Beavers are umbrella species, keystone species, and ecosystem engineers all wrapped up in one. Here's a typical lodge and pond on a really teeny Colorado creek. You can see how wide this pond is. Combined with the network of tunnels, canals, and channels that beavers build, it gives the beavers access to the full width of the valley without ever having to leave the water. Why walk when you could swim? That's how beavers think. So when we zoom out and look at the complex, and yeah, that's what we call them. The wetlands that beavers create are called complexes. Well, because they're complex. When a beaver population begins to expand into multiple colonies, the wetland expands too. And while sites like this seem rare today, a mere 200 to 300 years ago, most of Colorado's broad mountain valleys were a lot like this. Sit and let that marinate for a while. Well, that was just a few basics of beaver biology. If you want to learn more, check out this presentation by Tori Ritter from the 2021 Society of Wetland Scientists Beaver webinar. It's pretty awesome. Appreciation for beavers is skyrocketing. If you're new, there are plenty of good books you can read to get caught up on the beaver's awesomeness. Reading is great, but there's no way you can really comprehend the complexity, diversity, and sheer magnificence of a healthy beaver complex until you spend time in one. I'm serious. Get out there. You need to if you're going to appreciate this stuff. You should walk across one someday, but be prepared. It's not going to be easy. You'll understand why we call them complexes. Now go walk across a riverscape like this where the beavers are long gone. By comparison, it's like walking across a parking lot. The complexity's gone too, and so are many of the hydrological, habitat, and ecosystem benefits. Sadly, this is the image of an ideal mountain meadow stream we all grew up with. We all learned to draw lines, or draw streams as like squiggly lines, depicting a single channel carving through an otherwise mostly dry landscape. It's called Ecological amnesia. Compared to the simple incised channels that many of our streams have become, beaver complexes are ecologically rich, diverse, resilient, and dynamic. Left to their own devices, beavers make a wonderful mess of things, and that's precisely what makes them so valuable. Nice, simple, efficient, stable. This channel here, where the beavers have been gone, it's not messy at all. It's also not particularly complex or healthy. By comparison with the healthy beaver complex upstream, this section, a rough and tumbling creek, is ecologically depauperate and functionally wimpy. Joe Wheaton keeps reminding us, complex wetland riverscapes are not anomalies. They're natural. They used to be common. They could be common again. We just have to reimagine what our riverscapes could be. And when we do, we'll realize that we have before us the potential to restore wetlands on a grand scale, one that can affect the function and resilience of whole watersheds. And that's because beaver riverscapes like this, they're not only natural, they're also the most complex and biologically rich habitats we have in this state. They're stable, resilient, and self-sustaining. Wonderfully complex. This is Snowmass Creek, Tennessee Creek near Leadville, Cucumber Gulch near Breckenridge. One thing these amazingly complex Rocky Mountain riverscapes have in common is, yep, beavers. By partnering with beavers, we don't have to design and build wetlands. All we have to do is help restore the wetlands that were there naturally for thousands of years before we disturbed them. Lena Polvey and Ellen Wall studied Rocky Mountain alluvial valleys and determined that complex antibranching beaver complexes likely dominated for most of the Holocene. Simple incised single-thread channels didn't show up until about 200 years ago. Uncoincidentally, that's right when the beavers were trapped out. New scientific models show that stream wetland corridors like beaver complexes are the natural pre-disturbance condition in most alluvial mountain valleys. The condition we see so commonly today, one where incised channels bisect mostly dry floodplain terraces, is often the result of human disruption. And the near extirpation of a keystone species, that's one awfully big human disruption. Brian Kluwer and Colin Thorne's stream evolution model makes this clear. The anastomosing wetland beaver complex is stage 0. The incised single-thread channel with the dry floodplain has evolved to stage 3 due to prolonged absence of beaver. Ellen Wool's recent Frontiers in Earth Sciences paper sums up the science nicely. I highly recommend it. The point is that biologically rich stream wetland beaver complexes get dried up and simplified when they devolve into simple incised channels. And when this happens, we lose valuable hydrological, ecological, and habitat functions. The pies on this chart show the level of habitat and ecosystem benefits that go with each stage. The shift from stage 0 beaver complex to a stage 3 incised channel represents a massive loss in wetland and a corresponding decrease in ecosystem services. The good news is that by restoring these degraded wetlands, we have an amazing opportunity to gain back a lot of what we've lost. If beavers have what they need to survive, they work indefatigably to restore and maintain complex stream wetland corridors, and that's because, as we discussed earlier, their lives depend on it. Deanna Laurel and Ellen Wold describe it as a positive biological feedback loop, the upper loop in this diagram. When you have enough beaver dams, you get backwaters and overbank flows. These flows support wetland, deciduous vegetation, and multiple channels. Abundant wetland is the aquatic habitat and food that supports beaver. Beaver build more dams and ponds, and the system keeps going round and round in a dynamic biological feedback loop that builds complexity and resilience. Yay, ecology! But when these biological processes shut down, simple physical processes take over in another feedback that maintains simple, incised channels with dry floodplains. Boo! You can think of the feedback loop as a biological engine that keeps these wetland ecosystems dynamic, complex, and functioning. It's an ecological machine, and the cool thing is that as long as all the parts are there, it functions totally on its own. And it has been for thousands of years. When you think about it like this, your job as a restoration practitioner It's not to design and build these systems. It's to get the important parts back in place so that natural processes can resume functioning. That's why we call it process-based restoration. Well, the title of this session was How to Obtain Beaver Benefits. And if you've followed me so far, you're probably starting to realize that it pretty much comes down to this. You want beaver benefits? Restore beavers in their habitat. I like the way Chris Jordan puts it. It's forehead-slappingly obvious. Go! Partnering with Beaver to restore many degraded wetland riverscapes is an obvious path to better habitat, more ecosystem services, and more resilient watersheds, so let's get to work. Of course, just because the solution's obvious doesn't mean it's always easy. Working with biological systems is inherently complex. There's so much we don't know, and the learning curve's steep. There are no guarantees. We need to approach this with humility, and that's not something most of us are used to. But that doesn't mean we can't be bold. Partnering with Beaver and using low-tech process-based restoration approaches, it's nothing like the commercial industrial version of stream restoration that's become popular and has become the norm over the past 30 years. We have to break that mold and think about restoration a whole new way. It's really about learning to work with nature rather than trying to control it. You don't need engineering firms and huge teams of consultants. You don't need giant construction companies and quarries of imported rock. And you don't need meticulous scientific data to prove you've even made a difference. It doesn't have to cost $1 gazillion. As you'll see in the rest of my slides, with some professional guidance, expertise, and experience, and with a good dose of humility, process-based restoration and partnering with beavers is something ordinary people can do to make a real difference. And the benefits are obvious. They're forehead-slappingly obvious. Speaking of ordinary people, this is Sherry Tippie, and thank you to Aaron Hall for this picture. If you don't know who Sherry Tippie is, go home tonight and watch Sarah Koenigsberg's movie, The Beaver Believers. Sherry was a hairdresser who, in the 1980s, got upset when people were killing nuisance beavers in Denver. So she took it upon herself to live trap them instead and move them to the mountains. 40 years have gone by and she's still at it. Nobody loves beavers more than Sherry. And her strategy of reintroducing beavers to wetland goes back at least 100 years. The most audacious example was when Idaho Fish and Game dropped beavers by parachute into the Frank Church wilderness, hoping they would take seed and populate their riverscapes. And the idea makes sense. If streams and wetlands were damaged by removing beavers, how about we just put them back? Unfortunately, though, and despite what some folks might have you believe, restoring degraded riverscapes is rarely as simple as just trucking in or parachuting in a few beavers and letting them do all the work. If you drop off some beavers in a site like the one in the background, one that already has good riparian vegetation and enough ponds and wetlands to support them, then your efforts are actually replacing or enhancing just the beaver part of the machine. So I say go for it. It's certainly better than offing them, and it might do a lot of good. But as a big-time restoration strategy, beaver reintroduction seems to be effective only in places where all the other parts of the biological engine are already in place. It's hard to scale this up to a level that solves the environmental and watershed problems that most of our watersheds are facing. One of the reasons is that most, if not many, of our degraded riverscapes have, unfortunately, become totally inhospitable to beavers. Riverscapes like the one in this picture have nothing left of the machinery needed to support them. There's no vegetation, and therefore no food or building material. And there's no ponds or wetlands or even relic dams to provide the aquatic habitat they need to survive. You can't just drop a beaver off in a place like this and expect her to restore it from scratch. You know, that poor little beaver is pleading, "Please, don't leave me here." And while it looks bleak, riverscapes like these are not a lost cause when it comes to partnering with beaver. Not like a long shot, but you got to be ready. You have to be in it for the long haul. If you've got nothing left of that biological engine, no beaver dams, no ponds, no wetland, no vegetation, then you got a lot of work ahead of you to get these features back before it's ready for beavers. I mean, You can try to mimic beavers with beaver dam analogs and other treatments on sites like this, but you better be ready to keep doing it for a really long time, at least until the vegetation comes back. Only then can you expect long-term help from your beaver partners. Restoring native woody vegetation isn't always easy. It usually requires interventions, and it always takes a long time. Well, it's probably okay if it takes a long time. We can be patient on streams like this. This beaver restoration success I'm about to tell you about was all about riparian vegetation, and it took more than a decade to unfold. The left photo shows the reach in 2008, looking pretty much like it has since the 1800s. The right photo shows the same spot in 2016, after planting willows and 8 years of managing livestock. And here it is in 2020, after the beavers decided there was enough food and shelter to move in. Look, all the parts of the machine are back. I'm all for playing the long game on difficult sites with poor vegetation. But at the same time, I say we take advantage of the even lower hanging fruit, the super low hanging fruit. So back up to Rough and Tumbling Creek, the degraded site I kept showing you earlier. On this riverscape, the stream is pretty much a simple incised single thread bowling alley of a channel, and most of the riparian zone is no longer wet. But in this case, the woody riparian vegetation is still intact. Our strategy on sites like this is to mimic beaver dams with beaver dam analogs to restore ponds and wetland, and to select sites where we can reasonably expect beavers to immigrate on their own. There, I finally said it. Beaver dam analogs, BDAs, what most of you have been waiting to hear about for the last 20 minutes. Well, a BDA is just that, a beaver dam analog, an analog of a beaver dam. We try to make them as close to natural beaver dams as possible, using the same materials that beavers use. They're purposefully low-tech and not at all complicated to build. In fact, they're actually really fun to build, and you get an instant gratification. But they're also meant to be temporary treatments that ultimately get absorbed into the riverscape. Here's some BDAs we built a few years ago on Cave Creek. You can see what we're trying to do here by mimicking the processes that beavers would normally provide, at least until the beavers can come back over and take over. You can read all about BDAs and other low-tech process-based restoration approaches in the free, yes I said free, Low-Tech Process-Based Restoration of Riverscapes Design Manual. The immediate hydrological response to a beaver dam analog can be very impressive, as these photos clearly show. Put in a dam, create a pond, voila! But remember that BDAs are temporary. Without beavers, they're actually more like abandoned beaver dams than active beaver dams. Real active beaver dams work so well because beavers maintain them incessantly, 24/7, just like that little beaver that I showed you in the video earlier. And that's something that none of us can do. The short-term goal of BDAs is to mimic beaver dams. The long-term goal is to promote and sustain beavers in the biological feedback loop they're part of, that ecological machine. Our measure of success isn't just how a BDA looks when we're done building it. It's also about how well we promote it and sustain the machinery that keeps the wetland alive and functioning. About 5 years ago, Joe Wheaton and Jeremy Miestas did a webinar called Cheap and Cheerful Stream Riparian Restoration. It was about using BDAs, but it was also about taking a fresh new approach to restoration. Compared to the old school engineering-based approach, partnering with beavers to mimic, promote, and sustain natural processes, well, it's definitely cheap. And as these smiles confirm, it's also definitely cheerful. It's also highly effective. And I hope you agree. The resources that you save by shifting from an engineering approach to a process-based restoration approach, they can be used to scale up the size of the areas we treat. You can start measuring project sites in miles rather than feet, and I think that's exactly what we have to do if we have any hope of making a real difference on stuff like climate change and biodiversity loss. This is Sheep Park, another site in Pike National Forest we're working on. Down in the bottom right is where we camped this summer. The dried out riparian area on the left is our project. It's over 2 miles long. There's an active beaver complex at the headwaters in the distance. Our goal here is to help those beavers upstream expand downstream and make the wetland wet again. Aaron Hall, who we'll be hearing from later in this summit, he helped us out for the better part of a week, and that's his little orange tent down there. Not a bad place to hang your hat, eh, Aaron? Those trees are where we camped. Those are bristlecones that are probably 1,200 years old. More than 3/4 of their lives were spent before the first trapper ever arrived in Colorado. How about that? This is Aaron and our friend Vicky putting in some posts in a BDA. Driving posts is fun, but the novelty wears off pretty fast. Lots of our BDAs, like this one, don't have posts. This BDA raised the water up about 2 feet to create a pond and activate side channels. Well, yeah, we might have gone a little overboard with the posts on this one. These photos are from Aaron, who thankfully took the time to stop and shoot a little time sequence of the construction of this BDA. There's an amazing amount of plant material in a big BDA like this. And it's a lot of work. But it's fun work. And effective. Here's what it looked like when we walked away. The goal on this one was to get the water high enough so it would activate beaver canals on both sides of the channel. When you're working at this scale, you can't get too caught up in the performance of any one treatment. We're looking for system-wide responses. So check this out. Those shots are about a week apart. Actually, they're about 2 weeks apart. Though most of these treatments are happening in the incised channel, what we're looking for is a response that comes across the riverscape. On super low-hanging fruit sites like this, a lot of the relic beaver infrastructure is still present. We're just helping the water find it again. Check it out one more time. Before, after the treatments. And I told you ordinary people can do this. And who says work can't be fun? Funner than school anyways. Here's Jessica doing her best mimicry. And if you start cutting and hauling sod, you get an instant appreciation for the beaver's tenacity and strength. Now we're on Reeder Creek near Kremling. More posts. That guy in the center of the frame is Paul Planer, one of our close partners who lives in Gunnison. Reeder Creek's a BLM site, and that guy on the left is Ed Rumboldt, state-level BLM hydrologist. He came to me 2 years ago with the idea to do low-tech beaver restoration demo projects on BLM districts across the state. He was thinking that if we just get this thing started, and if we involve as many local people as possible, it'll open up the floodgates for this kind of restoration statewide. Good plan, Ed. Something like 20 BLM staff came out to help on Reeder Creek the week we were there. These young, energetic folks are the future of restoration and the future of public land stewardship. It's learning by doing, and it's leading by example. There's a lot of worry and a lot of hand-wringing going on about how we're going to amplify this kind of work statewide. And this is my plan. To do good work, to do as much of it as we can, and to involve as many people as we can. To be open and honest about the results, and to keep learning. Speaking of young people, here's Paula Belcher. She's been managing these BLM lands for a long time. Reeder Creek was her idea. And here's a quick before treatment and after treatment shots from Reeder. They kind of speak for themselves. I think this is my favorite BDA picture I've ever taken. Strength in numbers, baby. Now let's go back to the National Forest, Gunnison Ranger District. This is Trail Creek in Taylor Park. And this would be a pretty nice riparian corridor, except that it has one of those big incised gashes running through the center of it, and it has no beavers. This site's about 3 miles long, and this photo is just looking at the bottom mile. And this is the A-Team. I call them the A-Team because all their names start with A. Also because they're awesome. Ashley Hom, Ashley Merkel from the Forest Service, and Ali Delgizzi, a local contractor from Gunnison, one of our favorite partners. What started about a year ago as their combined curiosity about beavers, it rapidly evolved into a group called the Gunnison Valley Beaver Believers. Restoration on Trail Creek is happening because of them. The Gunnison Valley Beaver Believers are as eager as the beavers they endorse. At one point, we had something like 40 people busy working, a drone, a film crew, a newspaper reporter, and dignitaries from the Forest Service and National Forest Foundation, all on this site at once. It was kind of crazy. But there was lots of learning and lots of doing. That guy in the colorful shirt there, that's Scott Hatfield of the Beaver Working Group. And that's Paul Planer working with Nicole Fox, also from the Beaver Working Group. And her thing's called Give a Damn. More mimicking beavers. The Trail Creek Project brought together folks from several Forest Service districts, high country conservation advocates, Gunnison County Sustainable Tourism and Outdoor Recreation, and a bunch more ordinary people who just wanted to do what they could to help beavers. The project was sponsored by National Forest Foundation and was funded by Coca-Cola. Turns out that Coke and PBR go pretty well together. Cheap and cheerful. I'll finish with a few quiet shots of the work on Trail Creek. Again, it speaks for itself. But it's the big picture that matters. This is the lower part of the project reach. This is an abandoned beaver dam at the upper part. Well, let's just see how the responses looked. Before treatment, about a week and a half later, after treatments. Again, it's these super low hanging fruit sites that I think are most exciting. Most of that beaver created infrastructure's there, just helping the water find it again. There's an ecosystem engineer with 5 million years experience, anxious to partner with us in restoring Colorado mountain riverscapes. And what I learned this summer is that there's an amazing number of eager people who want to help too. Let's help them help us. Thank you.